Welcome everyone to another search seminar. Mark, you have 50 minutes. Take it away.
All right. Well, thank you very much for having me. I'm Mark Whitmeyer. I'm at the Arizona State University, and this is joint with Pak Hung Ao, who's in Hong Kong. And this is Attraction versus Persuasion, Information Provision in Search Markets. So actually, before I get to the motivation, I'm really happy to present this here. I came at this problem from kind of an information economics starting point rather than from a consumer search. And most of the people with whom I've spoken about this and most of the talks I've given have been to people who are primarily interested in information economics. So it's really nice to kind of get your point of view as well. Okay, so the motivation is in the standard models of sequential consumer search with imperfect information, many of the papers are variations on the following. So they're consumers, possibly heterogeneous, they visit firms in sequence, visits are costly, at least for some consumers, and during visits they observe prices and match values, and then at some point they stop and purchase or stop and exit the market. And the primary focus in the vast majority of the literature is on the pricing decisions of firms. So there's the literature on obfuscation, which is more related to what I'm doing, but still the primary focus is on pricing. And so what we do in this paper is we take the stance that the information about products comes from somewhere, and it's reasonable to treat it as a choice variable. So firms have a large say in what information consumers' visits will glean. And so given this, a number of questions arise. How does competition shape information provision? How do search frictions affect such competition? And do the standard predictions and insights from price competition, which I think we understand very well, carry over? Okay. So this is an overview of the model, and I'll get to the formal model very soon. So we look at a number of ex-ante identical firms selling goods with unknown match value to a single consumer with unit demand. So in the paper and in this talk, we're going to abstract away from price competition. So they're going to compete through information provision alone. So they're going to provide information about their goods to the consumer, and they're going to do this as follows. So they're going to commit to a signal or experiment about the quality or match value of its good before the consumer search commences. And so each firm's signal, importantly, is publicly observable to the consumer before the consumer commences on her search. And then when she visits the firm, the consumer observes a signal realization, updates her belief about the quality of the product, the match value, and then decides when to stop and whom to select. And of course, it's costly for a consumer to visit a firm. And so the key force is that the firm's information provision policies will affect the consumer search, not only through the realized signal, so it's not only through the signal realization, but through the signal itself. So the consumer search will actually be guided not just by what she sees, but what she will see, which is an endogenous object. Okay. Right, so this is directed search from the perspective of the firms. In the main environment, we'll look at costly search with this posted information. So again, the consumer observes the signal choices prior to search, must visit a firm to see its signal realization, and each visit requires that the consumer incur a cost of C. And then, so I actually don't have the first benchmark in this talk, but I will talk a bit about the second benchmark. So in the first, one natural benchmark is where there are no search frictions, and so the consumer can get all the signal realizations for free. And then the second is when information is hidden, and this is where the signals are not publicly posted, and much like the hidden prices models. Okay, so here's a preview of the results. So we find that there's a unique symmetric equilibrium of this game, and it has a particular linear structure. And this is due to the tension between attraction, you want the consumer to visit you, and persuasion, you want the consumer to select you. Moreover, we find that attraction may dominate. So if the average quality of each firm's product is sufficiently high, or there are sufficiently many firms, then full information is the unique symmetric equilibrium. And when we compare this to the case without search frictions, we find that actually the consumer may strictly prefer to have a small search cost and zero search cost, because it forces the firms to compete for her visit. On the other hand, if attraction doesn't dominate, so this is where the average quality in the market is low, or there are relatively few firms, then information provision is random. So we predict information dispersion, where firms will actually randomize over the signals they choose. I mentioned there's this, I'll talk about one benchmark, which is when information is hidden. And we find that much like with prices, when information is not publicly posted and therefore can't guide search, no useful information is provided. So this is just the diamond paradox in an informational setting. And then one auxiliary result, which we found interesting, is that there may exist asymmetric equilibria that are strictly better for the consumer than the symmetric equilibrium. And I probably shouldn't have this here because I may not get to it, but I thought it was interesting. Okay. So here's a collage I made where I'm trying to argue that there's at least significant causal evidence that firms seem to provide a lot of information to consumers, and moreover that they advertise it. So these are examples of firms advertising, saying, "Come visit us, and we'll provide you with a lot of information about the product." The piano is in a practice room at a Steinway dealer. And okay, so like I said, we also predict information dispersion. So again, this is very casual evidence, but these are the free articles per month offered by different newsrooms. And I hope that this is at least a little evidence that there's dispersion. They're providing different amounts of information. We also looked at least in software, there's a lot of variety in the length of trials, which again we think corresponds to different levels of information provision. I'm happy to talk about this more when I've explained what information dispersion is formally. Okay, so now it's time for the model. I have a bad habit of going too fast, so please slow me down if I'm unclear. Okay, so there are n ex-ante identical firms indexed by I. Each has a product with unknown quality, match value to the consumer. Match value is probably a better term for this, but quality is easier because this is directed search. So I'm gonna be saying reservation value a lot, and then quality helps me distinguish between the two. So the qualities are IID binary random variables. So either 1 with probability mu or 0 with its complement. And each firm commits ex ante, so it shares the prior with the consumer, but it commits ex ante to a signal, which is a stochastic map from the quality to a set of signal realizations. In this paper, we only need 3 signal realizations. So signals are posted, so the consumer observes these choices, but not their realizations, and then embarks on her search. So when she visits a firm, the consumer observes the signal realization before updating her prior about the firm's quality. And then at any point, the consumer may stop her search and select one of the products she has already inspected, ending the search. For this talk and for most of the paper, we normalize the consumer's outside option to 0, and a firm gets a payoff normalized to 1 if it's selected and 0 if it's not. The following questions seem reasonable. So what happens if we have other ex-ante quality distributions, for instance, or an outside, or add a non-zero outside option, or allow the firms to compete via prices? The main qualitative features of the equilibrium I'm going to tell you about survive to other ex-ante quality distributions. So in particular, if the match value, if the quality is distributed according to a prior with a density, the tension between attraction and persuasion remains. And again, we show that a large market or a high expected quality leads to lots of information being provided, and otherwise there must be randomization, there must be dispersion. The non-zero outside option is not a big complication, it just makes things a little uglier. And so we have a supplementary appendix where we talk about this. Adding prices complicates things a lot. So I guess I didn't go through the justification. So one of the justifications is that there are many, or there are at least some settings where firms cannot really compete via prices. So platforms will often significantly restrict the extent to which firms can compete via prices. So I have in mind in particular the Apple App Store, which does this, or the Nintendo Switch eShop. Another argument for the focus on information rather than prices is that we understand prices as an instrument. We don't really understand information, and before combining the two, which may muddle, it's useful to understand the trade-offs and incentives. Okay.
Just so that I'm making sure I'm following, can you just go back through what happens when in terms of the consumer's problem? Like what they know and at what point, like before searching a firm, after searching a firm, and then selection.
Okay, so very good. So the first step, the firms each commit to a signal. Okay, so the consumer then observes each firm's signal, and after that, the firm's problem is done. The consumer has observed each firm's signal. She decides whom to visit and in which order, and then searches in sequence, and then at any point chooses to either stop and select one of the firms she's visited before, or exits the market. So I think I will get into the
and searching reveals the exact quality, or like, because I think
searching only reveals a posterior, which is only the exact quality if they provided. Well, only if the signal realization is a fully revealing one.
Okay, cool.
Yeah. No, that's a good question. Okay, so this is standard in the literature. We can simplify the problem from one in which firms are choosing signals to one in which firms are choosing distributions over posterior beliefs. So Bayesians are always right on average. So the signal begets a distribution over posterior beliefs whose average must be the prior. And this is an equivalent problem so firms choosing these distributions is equivalent to them choosing signals. So we'll reformulate the pure strategy set for a firm to just be the set of all distributions on the closed unit interval with mean mu, and we'll call this set script M.
Can I disturb you for a second as well? So the IID assumption, are they stuff IID across consumers and firms, or just across firms? The qualities.
So there's no consumer heterogeneity. We have a single.
Okay, so everybody. So then okay. So why wouldn't I always want to reveal that my quality is high? Because I do it ex ante before I know my quality. Is that the case? Okay.
Right. So
okay.
So
Thanks.
Okay, so the solution concept is subgame perfect Nash equilibrium. So the n firms are simultaneously choosing distributions. The consumer observes these choices, then chooses an optimal search policy. I should have just skipped ahead to this slide, sorry, with your question, Dan, because this is maybe clear. We assume that the consumer treats firms fairly if and when she's indifferent. The consumer's payoff is expected value of the product that she chooses net of the incurred search costs. And this is just a zero-sum game for the firms. Like I said, the selected firm gets a payoff of 1 and all others get 0. Okay, so we're almost to the results.
Mark, may I ask you a question if
Yes.
it's not disturbing?
No.
Can you go back to, I was just wondering, so I can in context of looking at and thinking about advertisements, I can see sort of their sort of realizations of signals. I can see playing the Steinway gives me some update depending on how long I drive the Mercury. Okay, I'm getting that. I'm wondering, can I concretize non-abstractly the idea of the firm committing to and the consumer observing what sort of signal it's got? I can see it sort of in the abstract sense, but I would have trouble relating that to any form of. Anyway, go ahead.
Okay, so my answer to that is I will go back to the beginning because okay, so I think my best attempt to try to justify this is as follows. So there's a nice quote about from Armstrong and Zhou on their one of their papers where firms are posting prices ex ante, and this is directing search. Price comparison websites are now a major part of the retailing website. So my argument is that this is also true for information. So there are readily accessible lists online that allow consumers to compare these disclosure policies. So take some sort of software, so grammar checking, music, whatever. Take one of these markets for pieces of software. So firms will determine the length, breadth, and depth of the free trials. And then they will go to lengths to advertise this. They will say, if you sample our product, this is what you'll see. So I think this corresponds pretty well to what we have in mind, this advertising of what you will see if you sample our product, if you try.
That's really nice. Thank you, Mark. And now it's very obvious. So you had it in your examples, like the 60 minutes in the Mercury or the how many days free trial or stuff. And it's another dimension to advertising that I don't know if we thought about before. So I like much your answer and that direction you got. So go ahead, please.
Okay, very good. Okay, so the roadmap for the remainder is most of the talk will be on the main environment, then compare to statics, briefly the hidden information benchmark, because I think it's going to be quite trivial, I think, to people here, and then maybe extensions, time permitting. So what does the consumer do? So once we figured this out, the interesting thing is then what the firms do, right? So once we know what the consumer will do, we'll just back that out, and then she'll just be an automaton. So the consumer observes each firm's choice, equivalently each distribution over values, and embarks on her search. And this is going to follow Pandora's rule from Weitzman's seminal paper. So at each firm, she observes the signal realization, updates her prior about that firm's good. And eventually she stops and selects a firm. And this decision is again dictated by Pandora's rule. She wants to maximize her payoff net of search costs and has an outside option of 0. And a firm receives a payoff again of 1 if it's selected and 0 otherwise. Okay, so after observing the signal signal choices. She's faced with n firms containing a random reward, xi, distributed according to CDF fi, along with an associated visit cost of c. And so the seminal result of Weitzman is that you can fully characterize a firm, at least from the perspective of the consumer, via its reservation value. And so this is the formal definition. I think everyone here is familiar with this. It's each firm gets assigned a reservation value UI, which is just the expected value of the maximum of the difference between the random variable and the reservation value and 0. And this fixed point, which is equal to C, pins down UI. Sorry, that was a bad way of explaining it, but you guys understand it. So,
hi, Mark.
Hi.
Yeah. So because you just showed the Weitzman, so here, attraction means that you want to be the first person to be selected by this, visited by this consumer, right?
Right.
So for that, of course, full information is best. Full information maximizes the attraction, but probably that's not going to be. So that's the trade-off, in this problem, right? So like on the one hand, if you want to be the first person, you want to reveal all the information, but of course, ex post may not be a good idea. So that's what's going on here, right? Okay.
Yes, very good. Yeah. I thought you were going to mention your reformulation, and I was going to say, wait, soon. Okay, so the optimal policy. So this is all thanks to Weitzman. It's characterized by the following two rules: a selection rule. So if a firm is to be visited and examined, it should be the unvisited firm with the highest reservation value, and a stopping rule, which says that search should be stopped whenever the maximum reservation value of the unexpected firms is lower than the maximum sampled reward. So I'm not sure I said this already, but importantly, this is search with recall. So the consumer can go back and cautiously select a firm whom she has visited already. Okay. And I think Teddy, this is related to Teddy's comment. The reservation value rewards informativeness. So if a distribution F is a mean preserving spread of G, then it will be assigned a higher reservation value. And again, this hints at the attraction incentive. If you want to be visited early, so higher reservation value, you're visited earlier, you have to provide more information. Okay. So more on the reservation value. So the maximal reservation value is U bar, and it's uniquely induced by full information. So this is specific to the binary setting. This is not true. It's always uniquely induced by full information, no matter the prior, but it's not uniquely induced by full information if you have, for instance, a prior with a density, at least not in general. But this is not a big complication. Anyway, the minimal reservation value is U underbar, and it's induced by any distribution supported entirely above mu minus C. And of course, this includes the degenerate distribution, where you provide no information. And unsurprisingly, the firm can induce, by its choice of distribution, any reservation value between the minimal and the maximal one. So now we're moving along great. We're now to equilibrium. So is there a symmetric pure strategy equilibrium? And the answer is sometimes. So if firms have high expected quality, then one exists. If and only if they have high expected quality. So this is if mu is sufficiently high or the number of firms n is sufficiently large, and all firms provide full information. And here's explicit cutoff. I think this will become more clear in a couple of slides. And to get at this proposition, we can first establish this lemma, and then the next slide will finish it. So the lemma says there are no symmetric equilibria in which any reservation value other than the maximal one is induced. And this is very easy to show. And this is entirely due to the attraction motive. And the idea is that if you pick any other reservation value, firms cannot be providing full information. So this is like Bertrand competition with pricing above marginal cost. Why? Because there, firms can undercut the other firms by lowering the price infinitesimally, getting a discrete jump in their payoff. Firms can do the same thing with information. If other firms are not providing full information, they can just provide slightly more information, move to the top of the consumer search order, and it will get a discrete jump up in its payoff because the other changes to the distribution will be negligible. Okay. So this is on the road to uniqueness. We've just shown that if there's a symmetric equilibrium, it must be full information. And then we just need to check deviation. So if all firms are providing full information, then a deviation ensures that the deviator is visited last. Okay, but it may be good to be visited last because if you provide no information, say, you'll be selected for sure if you're visited. And then this is where the cutoffs come from. So if the average product quality in the market is high or the market is large, such a deviation is not profitable because even though you'll be selected for sure if you're visited, the chances that the consumer ever gets to you is just too low. On the other hand, if it's a very thin market, such a deviation may be profitable because so you're not visited first, but you can pick up the scraps because it's likely that they'll visit you and then you'll get them for sure. Okay. And so if the quality is not high, the market is large. The relative importance of attraction is small, and now persuasion is at least comparatively more important. And so there are actually no pure strategy equilibria. We know that we can't have any intermediate, sorry, this should say no symmetric pure strategy equilibria. We know we can't have intermediate reservation values, and then we also can't have the maximal one. Okay, so to tackle this problem, we're going to do a second reformulation. The paper Choi, Dai, and Kim observes, one of their main results is that the consumer's optimal shopping strategy affects firms' payoffs only through her eventual purchase decision. What you can do is define a new random variable, which is the minimum of the reservation value, which is deterministic, and the random variable xi, which is, again, this endogenous object. What they show is that a consumer's optimal search policy is equivalent to a discrete choice problem in which the firm just has a collection of these random variables, wi, and selects the firm with the highest realization of wi. So, this is really nice because we have this dynamic problem, and it can be reformulated into a very kind of simple static problem where you're just choosing the random variable whose realization is the highest. So this random variable wi is firm i's effective value, and it's a random variable, so it has a distribution, it equals to the original distribution fi for all values below ui, and then for values above the reservation value, it just equals to that reservation value. It has expected value mu minus c. Its upper bound of it can't be supported above u bar, and it can't be supported below 0, sorry. And if fi has a reservation value u, again, it must have an atom of size at least c over 1 minus mu u on u. Looking back on this slide, this is a mistake. I'm not sure how much you guys gleaned from this, but maybe it will be clear in a couple slides, or maybe you'll see the merit. Okay. So the last slide was a bit misleading. So it described distributions over effective values that can be induced by deterministic choices of signals. And we already know we're going to have to go beyond that because I just told you a few slides ago that we don't have a pure strategy. We don't have a symmetric pure strategy equilibrium. So they're going to have to be mixing over FIs. And this is very helpful because randomization, since signals are posted simultaneously ex ante, enlarges and also convexifies the set of distributions over effective values. So an example of this, the effective value distribution with support 0, mu under bar, mu bar, is inducible only via mixing, okay? You can't get this by a deterministic choice of FI. One easy way to see this is I just told you a few slides ago that the only way to get U bar is by providing full information. So this is clearly not inducible by a pure strategy. Instead, the firm can get this distribution over effective values by providing no information with probability 1/2, full information with probability 1/2. Okay. So each HI induced by a pure strategy has mean mu minus C. And so this will be true for any inducible distribution over effective values where we're allowing randomization. Okay, so that will carry over. I think trivially. Unfortunately, what we'd like to do is treat this as a pure persuasion problem where you're choosing distributions over effective values. But there's and so this just means, we would want to say, look, we have this mean mu minus C. Can we just say we'll choose any distribution whose average is mu minus C? And unfortunately, we can't do this. So because not all distributions over effective values with this mean can be induced even if you mix. So firms face a more complicated problem than just choosing distributions over effective values with mean mu minus C. So there's an additional constraint. Okay.
Mark,
okay.
can I go back there?
Yes.
You might be getting to that. I'm still back on the content of the advertisement. So
Yes.
would this be, you get to the store and then the storekeeper rolls the die and you either get the full 60-minute trial that tells you everything, or you aren't going to get a trial at all? Would that be yeah? Go ahead.
No. So this is randomization at the ex ante stage. So this would be when the firms are deciding the length of their trial offers. That's when they're randomizing. So the consumer will know the length of her trial offer, but what this will generate is the heterogeneity that I claim that we see. So the randomization is crucially at the ex ante stage. So the randomization is within the game played by the firms, but then the consumer knows the distribution she'll see. That's a very good question, because that's the time of the
firms sorry. So, but rival firms do not. Is the idea of ex ante choice, right? That the firms are choosing these simultaneous with each other. So the other firms don't know the actual realization.
Yeah, that's right. That's okay. Right. So exactly. So the signal choice and randomization over signals, this is a simultaneous move game or simultaneous move stage ex ante by the firms. That's right. So they can't respond. Yeah. Okay, very good. Okay, so maybe it's helpful also to, before talking about this slide. So remember, our goal is to characterize the equilibrium, the symmetric equilibrium in the game between the firms, and so the purpose of the slide is to discuss the best responses of each firm and how even to determine the best response of each firm. Okay, so to find a firm's best response, we can write payoff function pi, which is a function of the effective value, the firm, of the firm's realized effective value. So again, remember the firms are facing, each firm is going to face this a payoff function, and each firm is now choosing a distribution over effective values, okay? And this problem of choosing a distribution over effective values can be decomposed into 2 steps, okay? So first, fix a reservation value within the, the set of feasible reservation values, okay? So I said this very quickly, but a few slides ago I said that remember a reservation value of any reservation value requires a mass of at least C over 1 minus U to be placed in value U. Okay. And it turns out that we can always have the firm just place that mass on U and no more. Okay. So this is a firm's fixed persuasion budget. So a firm must place, if a firm is choosing this reservation value, it must place at least this amount of mass on U. Okay. The remaining mass, A of U, is this expression here, and this is a firm's flexible persuasion budget. And this is what the firm can freely do on the interval 0U. And when we're just looking at the firm's persuasion problem, so this is choosing a distribution of effective values, we can just focus on the flexible persuasion budget, because the fixed persuasion budget the firm can't control, and the flexible persuasion budget the firm can spread or do whatever with. And so this is with the flexible persuasion budget, this is the standard candidates against Cal problem of choosing a distribution whose average is the prior, but with this, the average is just this A of U. Okay. And then, given the solution to the first step, then the firm then optimizes over U itself. So this is how to determine the best response. And so the big reason I think why it's useful to talk about this is this encapsulates the key trade-off of the model, which again is attraction versus persuasion. And we see it right here when determining the best response. A higher U means more attraction, but it means a smaller flexible persuasion budget. Right? So you have less to work with in your persuasion problem. Okay.
Mark, can I ask you? I've lost track of why this residual mass is a persuasion budget. If I can put it absolutely anywhere, then can't I put it in places where it doesn't make sense to call it persuasion? Does my question even make sense?
No, that's a very good question. That's a very good question. So that's absolutely right. It's right from the perspective of the other firms. From the perspective of the firm that's best responding, this is unless parts are put on U itself, then this is all pure persuasion. It's true that if they put some of this on U, then we're thinking of this more. Then it's no. So I'm not explaining it very well.
We can come back to it at the end if you prefer.
Yeah, let's talk about it at the end. I should think of because that's a very good question. I have an answer, but yeah, it will take, I think, maybe some time. Very good. Okay, so now let's talk about the equilibrium. So like I said in the preview of the results, we find that the equilibrium must have a linear form. I restate that here. A firm's payoff as a function of its effective value must be linear in its effective value. So this is the equilibrium payoff. So it's easy to see that there can be no interior atoms. So this is in the distribution over effective values and hence in the payoff function a firm faces. And the reason is if other firms place an atom at some value, and it doesn't matter whether it's a reservation value or whether it's a posterior realization, it's never optimal to respond by placing an atom there. So if W is a reservation value, then offering a more informative signal improves attraction. If it's a posterior, shifting the weight to a marginally better posterior improves persuasion. It's a little more complicated, but it can be done to show that then the equilibrium payoff can't be convex and can't be concave. I mean, the intuition for why it can't be convex is because if it's convex, then no one wants to put no one wants to have any support of their distribution in the region where the payoff function is convex, because they'd rather just push it to the endpoints. And for concavity, if it were concave, they'd want to put masses, and we know that can't happen. Point masses are possible in the equilibrium payoffs on the zero reservation value or on the maximal reservation. On the zero value or the on the minimal expected value or the maximal one. And this comes back to the fact that the only inducible distribution with the maximal reservation value and support is the binary distribution, so which corresponds to full information. Okay, so this is necessity of the form, so then this is the equilibrium when mu is low or when n is low. And so
you you have 8 minutes.
Okay. No, that's good. Okay, so I probably won't get into the details. If the quality is low, they choose each firm chooses the following distribution over effective values. And the key thing is that when you take this to the n-1 power, this is just yields a linear payoff function. So the previous slide was necessity. Sufficiency is relatively easy. The difficult part of sufficiency is actually showing that you can each firm can induce this distribution, and we do that constructively. That's in the details. Again, I won't go into it. One interesting thing is it can be induced by randomizing over binary signals. So the firm will face n firms, each with unique binary distributions, because so this is the intermediate realization of a compound distribution. So so each firm has a different binary distribution. So this is the information dispersion. And one interesting thing is they can be ranked according to informativeness. So it actually begets at equilibrium a much simpler optimal search protocol. Even Weitzman's rule isn't needed. You just visit firms in order of informativeness. Okay, with medium expected quality. So if you remember high expected quality, so this is mu sufficiently large that they provide full information. And we adjusted low expected quality where there's an atomless distribution over effective values. As one might guess, the medium expected quality is a bit of a mix of the two. So now there's an atomless portion, so the payoff will be linear on the interior, but then there will also be point masses on both 0 and U upper bar. Like the previous construction, this will require a continuous distribution over binary signals, but now firms will provide full information with positive probability. Okay. I put in this figure to maybe aid in understanding the proposition. So this is an equilibrium payoff for 3 firms and mu of 2/5. So this is the payoff as a function of the realized effective value. And the question is, why can't we have this splitting, which would yield a firm a strictly higher payoff? And the problem is this isn't inducible. Instead, if you're going to get the maximal reservation value, you must be providing full information, and so this is maybe provide some intuition as to how we can have these mass points and still have it be an equilibrium. It's because of the fact that we need the mass points to provide full information. These are the 3 regions of U, mu, and n. So the x-axis is n, the y-axis is mu, for the region in which firms provide full information is quite large, as you see. So I think probably, given the time, it's probably most useful just to spend time on the next few slides, and so I won't get to the diamond paradox or any of the extensions, but actually I think this will be a nice conclusion because it compares what we found to I think some of the things we know from the literature. I've mentioned these probably ad nauseum. There's a search order effect, which we call attraction, which is the incentive to disclose more information and be visited first. And this is in constant battle with the pooling effect, which we call persuasion, which is the incentive to pool information so that the consumer will select you. With a high average quality, the first effect dominates. So it's all important to be visited first. So attraction is the most important. And then with low and medium average quality, the trade-off between the two leads to mixing. And so this engenders information dispersion. We can compare this to the literature on price-directed search. So there are a number of papers that, and I'm sure I'm missing others, that look at the problem of firms posting prices and then consumers observing these prices before searching. And these papers also generate price dispersion unless there's significant consumer heterogeneity. And importantly, in these papers, there's this tension between attraction, persuasion. So again, I'm using the definition of persuasion from the previous slide, and extraction, right? So price is the instrument, but there's a different tension. So a lower price means that you improve at both attraction and persuasion, and at the expense of extraction. Okay, so here, with these price-directed search models, attraction and persuasion act in synergy. Again, the tension is what you can extract via the price. We don't have the extraction motive in our paper. It's just a zero-sum game. But now with information as the instrument, the attraction and persuasion motives clash. So this is something you don't get at all with prices. So, one of the predictions, I know I have 2 minutes. I think everyone here at least agrees that we see price dispersion. Right, in this well-known quote by Varian. Do we see information dispersion? We certainly don't talk about it. But, my claim is that, one of the reasons is, there's a relative absence of theoretical predictions. It's also hard to observe and hard to quantify, but we predicted. Okay, and so I think I will probably end on that because I spending a minute on comparative statics probably is not worthwhile. So I'll just skip to the the thank you slide.
Thank you for a great presentation. We now open it up to questions.
So if I could ask a different question, and this is probably, even though you might be disappointed for me to say this, that might slightly still not be quite getting persuasion, but I might be having a semantic difficulty here. Is persuasion, can you persuade me persuasion is the best word? It seems like what's happening in your model is that it's more like I'm hiding, you call it pooling at some point, more shrouding. You know, with your analogy, which was really helpful at the end, by the way, about comparing it to standard choose price literature. Persuasion is clear, I'm persuading you with a low price. But here it feels more like I'm obfuscating. It feels like a negative word. Really, I'm not just debating English with you. I want to know if I'm understanding correctly, but maybe this is the way I'm doing it.
So that is very good. Okay, so you're absolutely right in that we are treating persuasion as the, or at times we are treating it as the pooling of these beliefs above the pooling of beliefs in order to get the consumer to select you, which in this context means that you're pooling them above some value, either be at a reservation value from another firm, given that they visited you first, or whether it be a realized value in this if it's in this, if it's just in this competition over realizations. Yeah, so I mean, one of the reasons, so this is, I think, the incentive we find just in the pure persuasion literature. This incentive to pool beliefs to pool on beliefs that lead to favorable outcomes by the recipient of the persuasion. No, I'm sympathetic to it as a bad term. Maybe attraction versus obfuscation is better, but I on the other hand, I think the fact that the tension is between spreading, which is obvious, which is the corresponds to attraction, versus pooling, I think that is important, and I'm not sure if even thinking about it, if obfuscation is better. Sorry, that was a really roundabout answer. Did that answer your question?
It was nice to hear you think about it, and it was helpful to hear you do that. I want to let anyone else ask a question. I have one other. I guess that's other people's time up then. Okay, so I want to again think about the application and this sort of motivational point you make about it perhaps being reasonable, at least in the cross section, to think about information dispersion in terms, and evidence being in terms of the free trial length or something like that. This is a bit, I mean, I understand that the model has this one-shot decision for the information design of firms. They all simultaneously make their choice. But of course, when we think about taking that, literally into application, pure mixed strategies are not ex post Nash, and I'm going to have an incentive to deviate immediately afterwards. My sense is that if you saw that data you presented in the bar graph over time, firms wouldn't be changing their strategies very often, is my guess. I don't know. It might be more convincing, like price dispersion papers often show the few markets there are where prices jump around all over the place almost daily. There aren't actually many markets like that, I don't believe, but that's what they do. I wonder if there's a similar graph that you could produce that would show something like that. Yeah.
So this is, so first, I think that's very interesting. So this may only be tangentially related to your question, but I think one of the sort of counter arguments we can have is that at least if we think about these software markets, there are significant frictions to changing your information provision policies, because developing these trial versions takes significant time and effort. And so unlike with prices, which can be changed very quickly, it may not be possible, at least in the short run, for firms to adjust their information provision policies. So this does two things. This one supports the simultaneous move aspect of the game, where firms don't play sequentially because they can't, because again, they've decided what the Spotify free trial will look like, and it's hard to adjust it. And then the second thing is that this may mean that, again, you wouldn't see the sort of rapid movement you do see with prices. I guess the one sentence answers that there's structural differences that may mean that information dispersion doesn't look like price dispersion in the sense you're saying.
Following up on that, so I think the idea of trial software, I think, was I see the point, but like going back to some of the other examples you used, those would not work quite as well. Like my assumption is any news agency could change from 10 free to 15 free articles with a pretty quick programming change.
Right.
But even Spotify, like I think back to Hulu, when Hulu started, there were almost no ads on their free version. Over time, the ads built up. So even then, there are ways of kind of eroding, but on different dimensions. That's not necessarily on informativeness, but on the kind of loss of value with the trial, like the free version. Spotify, similarly, I think they've still got a free version, and then a trial is different. So my point is that it's not clear because you start getting this interaction with value and informativeness.
Yeah. No, that's a good point. Yeah.
And then you get into what I assume you found with prices, which is that things can get more complicated. A different question. When you start considering more than just like a richer structure on match values or qualities as you've got them here, I assume this all gets a lot harder. But do you think you'll find similar results, or do you think a lot of this is being driven by essentially it either fulfills a value need or not?
So no, so the qualitative features survive. So I can now explain in more detail. So what we find is that, again, if the market is if there's sufficiently many firms in the market, we find that there's a unique symmetric equilibrium in which firms provide full information. If the market is large, but maybe not quite as large, depending on the prior, in the unique symmetric equilibrium, firms will induce the maximal reservation value, but will not provide full information. And what they'll do is they'll garble match values in a particular way that lie below the maximal reservation value. And the way they do this is the way that is discussed in, so Teddy Kim, Ralph Boleslavsky, and Iru Huang have a competitive advertising paper. I think that's R&R at the AER. And so that actually tells you exactly how the firms will compete for the measure below this maximal reservation value. Then, depending on the distribution, if there are even fewer firms, then there is no symmetric pure strategy. And this is where things get really, we don't know how to solve it for a prior with a density, because the problem of characterizing what distributions over effective values you can get is very difficult, even with a binary prior. So I see that as hopeless. I mean, maybe one cleverer than I could do it, but
that makes sense. I'm going to cut the recording here, but we can keep talking.